wonder where your morning cup of coffee is sourced from?
I do.
Let's talk about it.
As the coffee expert, to answer your question, there are two forms of growing coffee. There's sun-grown coffee, which is likely what you drink, as it makes up 76% of all cultivated coffee, as well as shade-grown coffee, which may look like a mess to you and makes up only 24% of cultivated coffee, but actually has many ecological benefits.
Excuse me, I would love to hear more about the differences in environmental impacts between these two systems.
Sure. To answer Claire's question, we performed an LCA analysis of these two coffee growing systems, those being shade-grown versus sun-grown coffees.
Excuse me, Audrey.
Yes, Claire.
I heard that the processing of coffee from coffee cherries to green beans can also affect the impacts of coffee growing as well. Is that something that you looked at in your LCA?
Very good question, Claire. Yes, we did look at this. There can be major differences in the environmental impacts depending on what processing method is used to get from the coffee cherries that are picked off the trees to the green coffee beans ready for roasting. For this, we compared two systems, which were naturally dried coffees often used in shade-grown systems, which can be seen here, and this system harnesses the power of the sun in order to deshell and dry the coffee beans. And we compared this to the wet milling systems, which are often used in the sun-grown, conventionally grown coffees. This type of processing often uses more inputs such as water, electricity, fuel in order to process the coffees from coffee cherries into green beans.
Let's take a look at the facts.
What we have here is the system boundary for conventionally grown, sun-grown coffee beans. As you can see, to get from the coffee cherries to the green beans, it takes a multi-step process in order for the beans to be processed. This includes depulping, fermenting and washing, drying and dehuling, all of which requires many external inputs such as water, electricity, as well as fertilizer and irrigation for the growing process. This has the potential to greatly increase the environmental impacts of this system. Now we have the system boundary for the shade-grown, naturally processed coffee beans. For this, as you can see, it takes many less steps than the previously shown conventionally processed coffee. Since this system uses the sun as a means of drying, although it still has external inputs needed, such as electricity and a little bit of water in order to wash the coffee cherries straight off the tree, the impacts are much less due to the fact that it's using solar as the main means of getting the beans ready for roasting.
Claire, you've asked too many questions. Does anyone else have a question?
I have a question. Do you guys have a results table showing the environmental impacts for each system?
We sure do.
As you can see, the results table indicates when comparing 1 kilogram of coffee grown under conventional sun-grown coffee methods versus a kilogram of coffee grown in shade-grown agroforestry systems, shade-grown coffee methods have a lower contribution in almost all impact categories, with the exception of fossil fuel depletion and ozone depletion.
If those graphs weren't convincing enough, here are a few other reasons why you should choose shade-grown coffee over sun-grown coffee. For one, the agroforestry system that is set up creates better biodiversity and habitats for cute birds, such as this little guy right here. In addition, conventionally grown coffee farms also usually come at the cost of deforestation, which can often look something a little scary like this. In agroforestry systems, this adapts to the local landscapes and doesn't require the use of deforestation, which also greatly reduces its impacts and makes much more happier ecosystems that look a little bit more like this. And finally, one last reason that we'll mention is that agroforestry systems often do a really good job at improving the water quality in these local areas. This is because it helps improve water retention, and also due to the lack of fertilizers and pesticides that are needed in these systems, the local watersheds also really improve because of this.